Hello everyone, and a very warm welcome to all the UGC NET aspirants tuning in. You're watching this Master Glossary Explainer, and basically, this is going to serve as your ultimate high-yield revision capsule. If you've been struggling to clear your fundus and logically crack those tricky research aptitude MCQs for your JRF, you are in exactly the right place. We're going to break down the most essential theoretical and conceptual key terms you need to know, mapping out everything visually so it really sticks in your memory for exam day.
Okay, let's dive right into our syllabus for today. We have a highly structured journey through the entire life cycle of a research project: core concepts and variables, the art of sampling, data collection and methods, statistical analysis and tests, and finally, ethics and academic publication.
Section 1, Core Concepts and Variables, laying the foundation.
Now, whenever we do systematic research, we make testable predictions called hypotheses. And let me tell you, these constantly compete for marks in your exam. Let's say our prediction is more study hours increase your net score. Your null hypothesis, H0, is the absolute pessimist here. It claims there is zero relationship between study hours and scores. But your alternative hypothesis, H1, stands up and says, no way, a relationship definitely exists. You're essentially testing which of these statements actually holds true.
To test those hypotheses, we use variables. Think of the teaching method used in your classroom. That is your independent variable. It's the cause. It's what you manipulate. The student's achievement score? That's your dependent variable, measured purely for the effect. But listen, you have to be very careful to control your extraneous variables. These are those pesky, unwanted factors, like a student's baseline IQ, that will quietly introduce heavy bias if you don't keep them strictly in check.
Moving to Section 2, the art of sampling, selecting your subjects.
Since we obviously can't test every single UGC NET aspirant in India, we have to take a smaller representative sample. These methods are clubbed into two distinct buckets. First, probability sampling. Methods like simple random, stratified, and cluster sampling ensure every single unit has a known, non-zero chance of selection. It's literally like a lottery. On the flip side, we have non-probability sampling. If you use purposive, also known as judgmental sampling, or if you simply survey your own batchmates out of convenience, you carry a very high chance of bias. Knowing this distinction is absolutely crucial to avoid losing easy marks.
Section 3, Data Collection and Methods, Gathering the Evidence.
So now that we have our people, we need to gather the evidence. This is a major scoring area for the paper. The fundamental split here is between primary and secondary data. Primary data is your original, first-hand evidence. When you create a fresh Google form questionnaire or conduct a structured face-to-face interview, you're gathering highly original data, though it is quite time-consuming. Secondary data, by contrast, is information already collected by someone else. Think of government census reports or published academic journals. It's quick, it's cheap, but it might not perfectly fit your exact research need.
Next, let's break down our core research approaches. Quantitative research is strictly about numbers and statistics, like surveying 500 students to find their exact average marks. Qualitative research is completely different. It deals with words, descriptions, and deep meanings, such as doing a detailed case study of a single tribal school. And if you want the ultimate deeper and broader understanding, you combine them into a mixed method approach, blending broad surveys with in-depth interviews.
Now, what's really interesting here is that you will frequently see these core research types appear as matching questions on the exam, so let's rapidly define them. Experimental research manipulates an independent variable under strictly controlled conditions. Descriptive research involves no manipulation at all. It purely describes what exists right now. Historical research studies past archives to understand the present. And survey research collects data to describe the massive trends of a large population.
Oh, and we simply cannot forget action research. This is an absolute must-know fact. When a teacher faces an immediate classroom problem, like students being highly inattentive, they don't do a massive historical study. They do action research. Pioneered by Kurt Lewin, you systematically cycle through 4 steps. You plan a solution, you act on it, you observe the results, and you reflect on what happened. Plan, act, observe, reflect. Definitely memorize that cycle.
Before we wrap up data collection, let me clear your fundus regarding the 3 pillars of a good research tool, because this is a very high-weightage MCQ topic. Validity asks, does this tool actually measure what it claims to measure? Reliability asks, will I get consistent results if I repeat this over time? And objectivity ensures the entire process is totally free from the researcher's personal subjectivity or bias.
All right, Section 4, Statistical Analysis and Tests, Crunching the Numbers.
As we move into descriptive stats, don't panic if you don't like maths. I assure you it's quite easy to score on. Let's just look at this strict numerical boundary, -1 to +1. This is the range for correlation. If your study hours and marks have a correlation of +0.80, it shows a strong relationship. But here's the crucial point. Correlation absolutely does not prove cause and effect. It merely shows that two variables are mathematically dancing together within this strict boundary.
For foundational descriptive stats, you need to know mean and standard deviation. The mean is simply your central tendency, the average of your data. The standard deviation is the measure of dispersion. It basically shows the spread of your data around that mean. So, to put that into perspective, a very low standard deviation means your student scores are tightly grouped, right near the average. When we shift gears into inferential statistics, we use specific tests. Fire this definition into your memory right now, the t-test. It is strictly used to test the difference between exactly two group means. If you are comparing the net scores of boys versus girls, and you have a small sample with a normal distribution, the t-test is exactly the tool you reach for. Two groups, t-test.
Let's move to the next one and see how this builds. What happens if you have 3 teaching methods to compare? Well, the t-test can't handle it. That's when ANOVA takes over. ANOVA stands for Analysis of Variance. It's the statistical test used to find differences among 3 or more group means, and it calculates this by utilizing the F-test.
Finally, for stats, we have the chi-square test. The direct MCQ focus here is the term non-parametric. While the t-test and ANOVA assume a normal distribution, chi-square doesn't. It's specifically used for measuring the association between categorical variables. The classic exam example you'll see, checking if there is a relation between a student's gender and their subject choice.
And our final phase, Section 5, Ethics and Academic Publication, finishing with integrity.
Ethical research is totally compulsory under UGC and APA guidelines. You must secure informed consent, meaning your participants fully agree to the study after knowing the purpose and risks. And you absolutely must avoid plagiarism, the ultimate academic dishonesty of copying someone else's work without giving them credit. You explicitly need to memorize the software tools universities use to catch this, namely Turnitin and Urkind.
Let's neatly clear up some common aspirant doubts regarding publication terms, because these get mixed up a lot. A thesis is a massive, long document for a PhD or MPhil, whereas a dissertation is generally a much shorter research work for a master's degree. Furthermore, you have to know the difference between your lists at the very end. A bibliography is a giant list of every single source you consulted, even if you didn't quote them. A reference list, on the other hand, strictly contains only the specific sources you directly cited in your text. Formatting these properly, usually in APA style for social sciences, is crucial.
When you actually sit down to publish your final research paper, you'll follow a strict blueprint. This is the IMRAD format. It gives you the exact chronological sequence needed to present your work and score maximum marks on exam questions about structure. You begin with the introduction, detail your method, showcase your results, and finish up with a deep discussion.
We've covered a tremendous amount of ground today, from identifying variables all the way to avoiding plagiarism. And remember, all great research starts with a comprehensive literature review to find out what hasn't been studied yet. So I want to conclude this explainer by asking you this. As you review all these concepts, prep to ace your exams, and look forward to your future PhDs, what research gap will you fill in your academic journey? Keep that inspiration alive, and happy studying.